Warning: hydrochloric acid is a very corrosive acid that will cause instant blindness and severe skin burns if handled improperly. This method also uses the electrolysis of salt water, which will create toxic chlorine gas. First, we'll add salt to an uncalculated amount of water and stir it around till it's dissolved. If your salt says that it contains particles that may not dissolve, you should dissolve it in the mixture that will not form hydrochloric acid, and then add some of the dissolved liquid to the other container. After this, you should make sure that your water levels are relatively similar. These ones are similar enough, it should be fine. Then, you're going to get a piece of paper towel, should work good enough. This will act as your salt bridge, forcing hydrochloric acid to be made on one side and the base to be made on the other side. And then, after soaking it in one of the mixtures, you will put it in between. Right now, these are both the same saltwater mixture, but then we're going to apply this wire to the side you want to make hydrochloric acid, and this wire to the other side. This one has a piece of graphite on the end that won't get corroded, and this one just has aluminum for a lot of surface area. Doesn't really matter. And then you have your power source, which I'm using this RC car battery. It's 7.2 volts. Then, once you are in a ventilated space, you are going to want to plug this wire into the negative side of your battery, which conveniently on this one is the black wire, and then this wire to the red wire on the battery, which is the positive side. It might be different depending on where you live, so you should definitely find that out. I'm not going to plug it in inside because I don't want to die of chlorine gas poisoning, so you should definitely do this in a ventilated area. There is a problem with making hydrochloric acid from this method, because where you form the hydrochloric acid, other acids with higher pHs that are less acidic will also be formed, and you have to destroy these. After we make the hydrochloric acid, I'll explain how you destroy these acids. I tried to make this video as DIY as possible, so I didn't include a couple other methods, but I'll talk about them now. So for your salt bridge, instead of using paper towel, you could use like a kitchen cloth like this. It has more microscopic fibers that will help the process, and if you have better wires than ones like this, I recommend you use them. I have some better ones, but they're at my friend's house. I will be using them for this setup though, and more volts than 7.2 volts would be helpful, but you can probably still use them. While we watch the electrolysis of the salt water, I'll explain the issue of the other acids being produced. So, when chlorine reacts with water, it forms hydrochloric acid and hypochlorous acid. When hydrochloric acid and hypochlorous acid mixed in a dissolved solution, it will form chlorine gas and water again, forming an equilibrium reaction going back and forth over and over again. This means that at any one time, there will be basically no hydrochloric acid that isn't involved in this reaction until you are able to shift the equilibrium reaction to the side of the hydrochloric acid. To do this, you will need to destroy the hypochlorous acid. Hypochlorous acid is actually destroyed relatively easily. And the easiest way to do it without diluting your solution with other chemicals is to expose it to UV light. UV light interacts with hypochlorous acid to form hydrochloric acid and oxygen gas. The hydrochloric acid will dissolve in the water and the oxygen gas will bubble out. And then instead of having an equilibrium of chlorine and water and hydrochloric acid and hypochlorous acid, you will have 2 molecules of hydrochloric acid dissolved in water. This will significantly strengthen the acidity of the mixture. I am now leaving my chlorine water under UV light for a few hours to turn it into hydrochloric acid. Now, after being under UV light for a few hours, we will test the acidity of the mixture. I'm now collecting some in a droplet that I can then splatter onto a pH test strip to see how acidic it is. Wow, that is quite red. So we'll check what that means in a second. So, it looks about as red as a 1 under my lighting. I don't know how it looks through the camera, but it's about at a 1. And it's not immediately bleaching the pH test strip, which means I've gotten rid of the majority of the hypochlorous acid, because the hypochlorous acid will bleach the pH test strip. That's how you can know if you have hypochlorous acid. I will now test the hydrochloric acid's effectiveness. To do this, I put a zinc-coated nail in about 5 milliliters of the acid to see how fast it reacts. I have it on a time lapse here, and at first it didn't seem like much was happening, but now the bubbles were starting to speed up. I then noticed that they were starting to get a lot larger, and they were being created and bubbled off more frequently. And then all of a sudden, the reaction kind of started to take off, and more of them were bubbling off. And right about now, you can see the mixture is starting to speed up and react faster, as the mixture is likely heating up because of the exothermic reaction of zinc reacting with hydrochloric acid. The zinc will react with the hydrochloric acid to form zinc chloride and hydrogen gas, which is the gas bubbling off. Thanks for watching, and don't forget to like and subscribe.